Another way of achieving load balancing is the BGP anycast, which is a network routing technique typically used with UDP, but you can also use its implementation with TCP. Let's say you're visiting one of Google's web pages. What happens in this case is that your computer performs a DNS lookup and then returns an IP address, which usually is 8.8.8.8. One may think that this IP address is associated to one server because this IP is announced globally by Google DNS server, and hence it is the IP which is seen every time at any location. However, this is not the truth. So if there is someone in North America who wants to resolve a domain using the Google DNS server, they're going to connect to IP 8.8.8.8. But if there is another user in Asia also resolving a domain using the Google DNS server by connecting to IP 8.8.8.8, are they connecting to the same physical server? Actually not. They're not connecting to the same server, although the returning IP address is the same. In the case of the user in North America, BGP directs traffic between autonomous systems. It's going to direct the user in North America to the closest Google data center. And in the case of the other user in Asia, their BGP finds the most optimal route of their internet service provider, or ISP, in Asia. So from a global standpoint, this is how the BGP distributes the network load across the globe.